Hi, welcome back to my YouTube channel. Today we have to learn different types of concept, how to design and simulation of encoder as well as the decoder problem. So in our the theoretical concept, we also learn different types of encoder, 3:8 encoder, 2:4 encoder. Meanwhile, we also learn priority encoder also. And we learned decoder also. We have to take 8:3 decoder and 4:2 decoder and how to develop a program and problems on this decoder also we did it. And now we have to simulate the same concept by using the virtual lab. So because of that, we need to go for the virtual lab link. You just Google it for the electronics and communication engineering for the virtual lab. Say under that hybrid electronics lab, we have a list of experiment. If you click on this list of experiment, in these slides, we already did about with the code converter also. The same the link we also provided with design and simulation for decoder, encoder, multiplexer and demultiplexer. The next class will be move on for how to do for the multiplexer and demultiplexer. So today's class we should be learn about decoder and encoder. So click on that. So we should be go for the decoder, encoder for that one, implement, and we should go for the theoretical concept. So what is a decoder? It's a digital electronic circuit. Decoder can take the form of multiple input and we have a multiple output logic circuit. So that converts coded input into coded output form for that. See where the input and output codes are different. If n input in the decoder to the power of n output. It is called binary coded decimal decoder. So the main applications is data multiplexing, 7-segment display and memory addressing decoding. We are using this one. And the reverse about this is, see this is for the decoder truth table. So that decoder, we had to use the select line about that. We had to use 2:4 decoder. I require two select line because we have four possible combinations 00, 01, 1011. And we have to check for enable pin because I have to check my decoder is working or not. We are writing, so this is the priority decoder for that one. See, my enable pin is 0. I am not selecting any one of the select line for that one. Is it in off condition? I am not decoding anything. So whenever my select lines are 00, I am encoding my output line as 00. So because I have to just Q0, Q1, Q2, Q3, I have four output line. So my select lines are 00. I have to, my enable pin is 1. That is I'm working conditions. I have to decode. This is the first one. So what is the first one? This is the D0. This is the O01 has to be highlighted. So my select line is 00. I am getting that light and be on. My select line is 01 and the next value 01 has to be output, has to be decoded. My select line is 10 and the third category is O2 has to be get activated. My select line is 11 and the Q3 has to be get activated. So this is how decoder of 2:4 decoder. In the theoretical class also if you ask, define the decoder, write the truth table of decoder, so write the block diagram of the decoder and this is a pictorial representation. Two select line, one enable pin is one, then only our demultiplexer as a decoder has to be work. And we have a four different output because two have a input. See, this has to be realized. See, if you also go for 3:8 decoder also, this is most important for the exam purpose, right? The truth table for 3:8 decoder. So we have a three select lines, 00 to 11, because three select lines, we have eight possible combinations, 00, 001. Depends upon my select line and any one of the output line has to be decoded. My input is 00, it should be decoded to the first value. My input is 001, I am decoded for that the next value of that. My input is 11 and D7 has to be decoded. So because of that, 8 AND gates are required to realize for the 3:8 decoder. See, this is my select lines and this is the 8 AND gates. Inputs are 000. I'm providing for the first AND gate and this first AND gate Z not has to be get active. limited. See, this is for the construction for the decoder. So what is an encoder for that one? The encoder part I will take it later. Let I complete about the simulation part about the decoder. Those students, I got the decoder. You have to choose the decoder for that one. So we use the same diagram what we learned theoretical concept right now, 2 minutes back. Same diagrams are implemented here. We have the decoder 3:8 decoder, 8 different possible output and 3 different possible select lines. The select lines are S0, S1, S2. Depends upon the select line I am choosing and corresponding any one of the output line has to be get decoded. See, my input lines are 0, 0, 0. If it is run, see, according to that, whatever that the first is coming into here, see, this is my decoding value. See, 0, 0, 0. Decoded value is 0, 0, 0, 1. It's an 8-bit value. This is 0, 0, 1. If in case I am selecting 0, 0, 1, what is the expected output? So D1 has to be get 1. Run that value. See, now I got 1. See that I got my input is 0, 0, 1. See, output has to be 0, 0, 1. See, the same this also and the writing the exams also. You need to write this diagram. So then in the internals also we are providing for the decoders also. We guess next is 2 and this is 0. If it run, see it will get 2. The second portion 0, 1, 0. That answer is for this. See, if you are all are 1, 1 and if you run it, our expected output is for 7, the 7. So you need to take all possible combination of our input. If you take 5, so now take 1015 decoder output is fifth leak. Not all. Any one we need to be selected depends upon the my selected. So this is how to do for the decoder part 3:8 decoder. See if in case students got encoder concept. So let me go for the theoretical part. So what is an encoder part? Encoder is also a device. It will transduce software program or any algorithm or the person converts your information from one format or code to the another formats. The purpose of encoder is for standardization, speed, security, and saving the space by synchronizing the size. V8 is also one of the combination logic circuit. Its work opposite to the decoder. So what is an opposite to decoder? Encoder we have that is 2 to the power of n into n value. What is the 2 to the power of n? So we have number of inputs are 8. The outputs are decoded to 3. See octal to binary. It is also called 8:3. What is an 8:3? Octal to binary take 8 inputs and provides 3 outputs. See, this is the format I am getting. See, we have 8 inputs, I0 to I7. If in case I0 value is 1, I need to decode it that has to be 0, 0, 0. When I1 has to be 1, I need to decode it to 0, 0, 1. If in case I7 is decoded to 1, I need to take 1, 1, 1. See, this is, we need to do the circuit diagram class. You need to take that value of Y2. You take the summation of what is an output line of Y2. So whatever that 1 is present in the truth table, you take the corresponding value. See now, this is my Y0. Y0 wherever 1, this is the 1. What is the corresponding is I1 and this is the one corresponding is I3. This is the one corresponding for I4 and this is the one corresponding for I7. See, according to Y0 is written. Same way Y1. You take the Y1 wherever 1. Y2 wherever 1. You take out all those things. You need to write a logic circuit diagram. This is very, very important for your theory exam also. Design 8:3 decoder with block diagram. Then you might write a truth table, equation has to be written, and you have to write this diagram. See, the last previous second internals also we provided for the same question. You need to remember for this concept. Add on to that, we can also do for the parity encoder. What is the parity? As the name indicates, I have to give the priority for that number of inputs. In the simultaneously, more than one inputs are activated, then I need to decode my output, any one of that one. While decoding, whichever the number has the highest value of that one, see that number you need to decode it as in the output. That's the priority. A priority encoder is a circuit or algorithm that compresses multiple binary input to smaller number of output. The output is of a priority encoder is the binary representation of the ordinal number starting from 0 to the most significant input of the bit. See now initially the priority encoder, so I'm not selecting any one of the input line. The output is not determined. It should be declared as a don't care. And we have to take one more output name is 0 because this is not decoding anywhere. If my input is G0 is 1, output has to be recognizing as 0, 0, 0. Then B has to be get active mode in now priority encoders in working condition. If in case D0 is also 1, D1 is also 1. See then which one is highest number? D1 has highest number. I need to be decode as Y0 is 1. See, instead of I'm presenting D0 is also 1, I'm representing the X. X can be either 0 or 1. We are not looking to that one. Higher version of the value, which one is 1, that has to be decoded. The next number is D0 is also X, D1 is also X, D2 has 1. Then we don't bother about D0 and D1 either 0 or 1. But D2 has 1, I need to decode it to Y1 has to be 1 and 0. Similarly, for the last condition, that all the three inputs are X and final output is 1. Highest number is D3. We don't worry about all those things. So it is to be decoded to 1. So this is our priority encoder. The same process you need to take Y0 and Y1 and you have to take the block diagram of that. The same thing I need to realizing using simulation part. Go to simulation, choose the encoder. So we have 8 input lines. Okay. We have 8 input lines. I should be decoded into 3 output lines. 8 is to 3. For this, I need to select any one of the input. For example, my inputs are 0. It should be decoded to what? 0 only. This is one highlighting. Run it. 0, 0, 0, 1. 0, 0, 0, 0, 1. Y naught as a D naught has to be get 1. And the output has to be realized to 0, 0. If in case this is 1 and this is 0, if you run and D1, whatever I'm storing in D1, 0, 0, 1 has to be D. Okay. If in case both D1 and D2, this has to be get realized is run and this 0, 1, 0. This is D2 has to be get. If in case these 7s are highlighted, if we run that one, see now D7 is also there, D2 is also there. These simulations are designed as a priority encode of 8 is to 3. D2 is also 1, D7 is also 1, but highest one is D7. Because of that, D7 has to be decoded to 1, 1, 1. If in case D6 is also 1, the output is not changed because D7 is the highest one. I am getting 1, 1, 1. If we not use D7, then if we use D2 and D3 and D6, what is the expected answer? I have to get that expected answer has to be the D6 value has to be getting. So this is 1, 1, 0. See this, you need to take different possible conditions of your screenshot. So whatever I have taken, every steps you need to take a screenshot and that has to be make word copy and you need to be uploaded for that. See this completion of the topic about how to do for both encoder as well as the decoder. So the next class I will be more about how to do for the concept of multiplexer and demultiplexer. Thank you.